Well, hello everybody. What I need to do with you today is I'd like to cover section 1-2 with you. What I did is I skipped the skill check over section 1-1, the writing equation of the lines, figuring that should have been kind of easy. Now, this is a unique section to try to make a math video for. There's more talk than math in this one, so I hope it works out okay within the video. What section 1-2 deals with, it deals with supply and demand, equilibrium, and how to write equations basically from some word problems. So I'm going to click through this. What you need in front of you is you need your day 2, your section 1.2 notes. Now, they're a little bit different from my normal notes because they're my PowerPoint snips. So there's so many that I decided to go that route. So if you would, come over to this part right here. There's some major terms I need to define for you as we go along today. Supply and demand thoughts. Now these are just some snippets from the Apple magazine from years ago. It says the Apple iPad supply catches up with demand. Where I need to take you today, guys, is I need to make sure you understand what they mean by supply and demand. Now, come down here to this statement right here. It says, for the first time since the iPad 2's launch in the March of 2011, supply of the Apple tablets has finally caught up with the demand. Now, this is really interesting. Back in 2011, Apple was accused of holding on to some of their iPads. The iPads were very, very popular, and Apple was accused of holding on to them, not letting them come out into the market. Why would they do that? It would drive the price up. And then once the price was driven up a little bit, Apple all of a sudden had some, and they let them into the market. So that's what Apple is accused of by some people. So for the first time since the iPad's launch in March of 2011, supply of the Apple tablets has finally caught up with demand. Those are two big terms. Supply refers to what the seller is willing to let go. The demand is what us consumers want. So it says, demand has been staggering, and I'm not going to predict when supply and demand will come into balance, said Chief Operating Officer Tim Cook. Demand, once again, what us consumers are willing to pay, what us consumers want. Supply is what the distributor, the manufacturer, is willing to let into the market. So flip over to your next one there. It says, during the late 1980s and early 1990s, the consumer demand for cranberries soared. Now, I was around at the time, you weren't, but cranberries became the superfood. If you drank or ate the cranberry juice, you were going to live to be 100, you were going to feel healthy, all your ills were going to be cured. If you had cancer, it was going to be cured. Cranberries was the catch-all of everything. So it says, the demand for cranberries soared. The demand, that's us consumers. The demand surpassed the supply, causing a shortage. So prices skyrocketed. So if you had some cranberries, they really shot up in value. Since the price increased, growers wanted in on the action to increase their profits, so they planted more acres of cranberries. Now, this is really key. Unfortunately, cranberries takes 3 to 5 years from planting until they first can be harvested. Can you kind of predict what happened? Over that 3 to 5 years, the demand, what us consumers wanted, went down. The supply, because people had planted many, many, many acres of it, the supply had went up. So the demand went down, the supply went up, so the price just really bottomed out. The cranberries lost their appeal. They weren't as appealing to everything else. So So supply and demand terms that are really, really important. Demand refers to how much of a quantity of a product that the service is desired by the buyers. Sometimes it's referred to as the price. As we go here in a little bit, you will see little p. Little p represents the price of a quantity. Quantity demanded is the amount of a product people are willing to buy at a certain price, and supply represents how much the market can offer at certain prices. It also refers to how many units the seller is willing to sell. So there's a lot going on here today. So some supply and demand thoughts. As the price of an item goes up, the demand of the item declines. Think about that. Whenever you see the word demand, that's us consumers. So us consumers are going to buy less. When the price is high, us consumers are going to buy less. As the price of an item increases, supply. That's what the marketers have. That would be Apple. That's what the farmers have. The supply goes up. So if consumers are willing to pay more, the suppliers are willing to give more. So as the price of an item increases, supply goes up. That happens with wheat. That happened with cranberries. It happens with gold. As the price of an item decreases, the quantity decreases. Well, that makes sense. If the price of an item is lower, consumers typically will buy that item. The increase in supply, that's what the distributors are willing to let go, and the decrease in demand, that's us consumers, can eventually result in a surplus. Once that happens, stores do whatever they can to get rid of it. So they host a sale, or if it's a produce, they have to throw it away. You'll be amazed at the amount of produce that gets thrown away at Dillon's and Walmart and different stores like that. So, supply and demand thoughts. These trends tend to move the price as well as supply and demand towards what's called an equilibrium price. We talk a little bit more about the equilibrium price here in a little bit. If this is my supply and this is my demand, the equilibrium is that point right there in the middle. Now overall, mathematically on this lesson, that's easy to find. I'll show you that here in just a couple of minutes. Where I'd like to take you right now is I'd like to talk about watermelons, because watermelons taste really, really good at this point of the year. They're in full harvest, they're relatively cheap, so I decided we're going to talk about watermelons. So here's where this one comes from. It says, Albert is the manager of the giant supermarket chain called Mathmart. If you're clever, you will get that piece of humor right there, Mathmart. He has studied the supply and demand for watermelons. He has noticed that the demand increases, what us consumers want. The demand increases as the price decreases. When watermelons are cheaper, we consumers tend to buy more. When they're higher, we tend to buy less. He has determined that the quantity in hundreds demanded weekly and the price in dollars per watermelon are related by the linear function P equal capital D of Q equal 9 minus 0.75 Q. A very strange looking formula. But let me point some things out. Little p means the price that we are willing to pay. Throughout our studies, you'll see little p, that means price. You'll see capital P, that means profit. So whenever you see little p, that's going to mean price. Price is a function of the demand. Remember, the demand is what us consumers want. My formula is saying right here, the highest us consumers are willing to pay for a watermelon is $9. Every time I drop the price by 75 cents, I'm going to sell another 100 watermelons. So peek at my next little sheet here. So here goes the thinking. If us consumers are going to buy 100 watermelons, I'm going to plug 100 right there. 9 minus 0.75 times 100 gives me a price of 8 1/4. The revenue, the amount of money that I bring in then, would be 100 times 825. So the revenue in this case is $825. Well, what we need to do is toy with this just a little bit and see. What if we want to sell 300 watermelons? Type in 9 minus 0.7 times 300. That tells me the price that us consumers are willing to buy would be $6.75. And it tells me that my revenue, 300 times $6.75, would be $20.25. And then you can continue on down the chart. If I plug in 500 there, if I plug in 500 right there, boy, my PowerPoint. And if we continue to plug those numbers in, you'll see that at the quantity of 500, my price that us consumers are willing to pay would be 5 1/4. 500 times 5 1/4 gives me a revenue of $26.75 or $26.25. And notice that 700 and 900. Do notice this real fast, guys, if you would. Notice that somewhere in here, I seem to hit a maximum. And then it seemed to come back down a little bit. Now, finally some math to go along with this. The lesson has a lot of talk in it. The math portion is really kind of easy. It says, find the demand price of $5.25. Here's what this means. How many watermelons will be sold at a price of $5.25? Well, I'm going to plug in $5.25 in for P. And I'm going to set that equal to 9 minus 0.75 Q. Now I'm going to subtract 9, divide by negative 0.75, and I'm going to get 5. Now remember, our units is per 100. So that means 500 melons. So here's what we're predicting. If the price is $5.25, us consumers are going to purchase 500 watermelons from MathMart. Find the demand price at $3.75. Think about this as I write this down. I'm going to go $3.75 equal 9 minus 0.75 Q. Now, the prices just went down. So what will us consumers do? We will probably buy more. So if you subtract 9 and divide by negative 0.75, you're going to get 700 watermelons. So the price went down. Us consumers are willing to buy more. Now, let me go to the supply side of things. Albert's assistant, Pascal, noticed that the supply of watermelons decreased as the price decreased. Remember, now we're talking about the owner of the watermelons. If the price is low, he's not wanting to sell many. If the price is high, he wants to sell a bunch. He found that the price and supply are related by this formula right here. So I got the price is a function of the supply, and that's really 0.75 Q. So remember, now you're the owner of the product. You're the supplier. When the price is low, you're going to hold on. When the price is high, you're going to sell. So, come over to your next slide there. Find the supply price at 5 1/4. This is saying how many watermelons will the owner let go at 5 1/4. The math is easy. 5.25 equal 0.75 Q. Divide both sides by 0.75. The owner will let 700 watermelons go. If you run that through your calculator, you'll get 7, and then remember our units is 100. Find the supply at 3. Now notice my prices went down. So you, the owner, you're not willing to sell as many. So I'm going to go 3 equal 0.75Q. Divide both sides by 0.75 and get, oh boy, 4. So the quantity that the seller would be willing to let go in this case would be 400 watermelons. So guys, there's the stage of the math. Now, I'm going to slide a little bit. I want to show you this slide right here. If you're given the supply equation and you're given the price equation, the demand equation, if you're asked to find the equilibrium, you just set those things equal to each other. So I'm going to bypass a couple of spots here just to show you the math of it. So you have a slide for this that says the easy part of it is now. Find the equilibrium price given a demand equation of P equal 9 minus 0.75Q and a supply equation of P equal 0.75Q. Well, I'm going to take 9 minus 0.75Q and I'm going to set that equal to 0.75Q. So I set the supply equal to the demand. Now we're just going to solve this. I'm going to add 0.75 to both sides. So I've got 9 equal 1.5Q. I'll divide both sides by 1.5. So I'm going to get a quantity equals 6, which means 600 melons. So to make the grower happy, to make the consumer happy, we need to sell 600 watermelons. To get the price, take 6, not 600, take 6 and plug it right there or right there. It shouldn't matter either which way. If you do that and run that through your calculator, you're going to get a price of $4.50. So guys, that's how you find the equilibrium price. I've got a couple of slides in here that just talks about that happening. In real life, that never happens. That means the consumer buys it for, the store owner buys it for $4.50, sells it for $4.50, and everybody's happy. And we know in real life that's really never going to happen. So, now I'm going to switch gears a little bit. I'm going to talk to you about cost analysis. So, come back over to your cost analysis. Once again, I just got to throw some terms out at you and make sure you understand what they mean. The cost of manufacturing an item usually consists of 2 different parts. The first part is what we call a fixed cost for designing the product, setting up the factory, training workers, rent, insurance. The fixed costs are fairly constant. The fixed costs show up no matter how many units you produce. You're out the fixed cost before you even do anything. Now the second part is called the cost per item. We call that our slope as we do these. The cost per item takes in consideration the labor, the materials, packing, shipping, overtime, anything like that. Now in calculus you're going to start hearing the word marginal cost a little bit more. Guys, that just means slope, cost per unit. So here comes my simple example here. T-shirts R Us will charge me $25 to screen print any number of T-shirts and will charge me $4.25 per shirt ordered. What would my cost equation look like? Notation-wise, I'm going to use capital C to represent cost. Now within the problem, there's something per unit you produce, and then there's something that you're just starting with. That would be your fixed cost. In this case, my marginal cost is $4.25 per shirt. The $25 is my fixed cost. So there's my fixed cost. I get charged that, guys, whether I make 1 t-shirt or 100 t-shirts. And this is my cost per shirt. So let me see if I can go back a slide. So in this example, my fixed cost would be the $25. And my cost per unit, also called my marginal cost, would be 4 1/4. Going on to my next one. Cost function continued. We can produce the hottest game to ever hit the market. Wait for it, Mathnopoly. I gave you time to laugh there. For $10 per game. We know that we can produce 100 games for a total of $2,500. Find the cost equation given that it's linear. So some things that I know, guys. It costs me $10 per game. That is my slope. $10 per game. That's my marginal cost. Another thing that I know, 100 games will cost me $2,500. Now, this problem is relatively easy now. I know a slope, I know a point. Now go back to section 1-1. We need to write the equation of a line. So you could go y minus 2,500 equal 10 times x minus 100. And then we can solve this. Y minus 2,500 equal 10x minus 1,000. Add your 25 over and get 10x plus 1,500. Now my cost equation then would be, I'm just going to change the notation, 10x plus 1,500. Now, while I'm here, I wouldn't have used point slope form on this. I would have done this. 2,500 equal my m times my x plus b. I would have grabbed my calculator and then went 2,500 minus 10 times 100, and I would have got 1,500. And then I know my cost equation would be 10x plus 1,500. So there's my y equal mx plus b form. So there's our way to write equations. So a little bit of our last section within there. Last but not least, I'm getting close. Little things in the business world that's going to show up over and over this semester. Revenue is the amount of money that you bring in. In revenue, we do not care what your costs are. Revenue is just the amount of money that you brought in. Cost is the amount of money that you spent to make it happen. Your profit is your revenue minus your cost. Now, let me pause a second on this notation. Notation is, it says revenue equal R of X, which equal X times P. Guys, as we go, when we set up a revenue equation, it's going to be the number of units that you sell times the price. Sometimes it's the quantity that you sell times the price. Cost, our notation is C of X, and our profit is the revenue minus the cost. So come over to my next to the last one. Studies have shown that the cost equation to produce the widget for company D is C of X equals 1750 plus 1275. They sell the widget for $32.50. How many units must be sold to break even? Now, some important things here, guys. Remember revenue? Revenue is the price that you sell it for times how many you sell it. So my revenue equation is going to be the 3250 times X, where X represents the number that I sell. So there's my revenue. How many units must be sold to break even? We break even when my revenue equals my cost. The amount of money that I brought in equals my cost. Now the math portion is easy, so it looks like this. My revenue equation is 3250x. My cost equation is 1750x plus 1275. Now we're just going to solve that. Let's subtract away 1750 and get what? 15x equal 1275. Divide both sides by 15, and it looks like we would get 85. So we're going to break even when we sell 85, in this case, widgets. Now my part B. What's the profit if, let's change that is to if, what is a profit if 125 widgets are sold? Guys, now we need a profit equation. Well, my profit equation is my revenue equation minus my cost equation. Get to where you really know that formula. It shows up about 100 times from now to the end of the semester. So my profit equation becomes 3250x minus 1750x minus 1275. So guys, I distributed a negative sign. So my profit equation really becomes 15x minus 1275. There's my profit equation. What's a profit if we sell 125 units? Let's plug in 125. And then we can run that through a calculator. So it looks like if I do that, I should get $600 in profit. My part C, how many widgets must be sold in order to make $5,000? Well, what I want to do there is I want to set $5,000 equal to my profit equation. Add 1275, hit equal, divide by 15, and then you'll have it. Then it looks like I've got one last one for you guys. My goal was to get this video done in 30, and I'm going to be close. Here's my last one. Trying to get backing from the Sharks. I told them that the cost equation had produced the Math Nuggie. You guys have seen that one in my classroom. I told them that the cost equation produced a Math Nuggie is C of x equal 275x plus 1300. I sell the Math Nuggie for $18.99. How many units must be sold to break even? Well, to break even, my revenue has got to equal my cost. My revenue has got to equal my cost. My revenue equation is what I sell them for, $18.99 times X. So, to break even, I need to take 1899x and set it equal to 2.75x plus 1300. subtract 2.75, divide by that number, you should get a number but right at 81. So I would need to make 80 or 81 math nuggies. Just be careful of the verbiage as we go. What's the profit if, God, I got a lot of typos on this. What's the profit if 500 math nuggies are sold? Well, now I need a profit equation. So my profit equation is going to be my revenue, which is 1899x, minus my cost equation, which is 275x minus 1300. So my profit equation looks like 1624x minus 1300. There's my profit equation. Now to do this, the profit for 500 math nuggies, we would just plug in 500. So I would go 1624 times 500 minus 1300. If my scribbles tell me right, that's about 6820. And then how many math nuggies must be sold in order to make $10,000? I would just take 10,000 equal the 1624x minus 1300. We would add 1300 over, divide by 1624, and then you'd have your answer. And then, of course, my last slide, which you've accidentally seen 2 or 3 times because my PowerPoint keeps jumping, was there's a picture of the Math Nuggie for you non-believers. Notice that the Math Nuggie has various formulas written on it. So, good luck with the lesson. Come in and let me know if you have any problems. Your assignment is on Math Excel, section 1.2. Good luck.